Alright, so today we're doing an overview of the 4 trigs that we've been graphing. So we've been graphing for the past week tangent theta, y equals cotangent theta, y equals cosecant theta, and y equals secant theta. So just a really quick recap. For y equals tangent of theta, we're going to graph. So let's first recall that tangent of theta is equal to sine theta over cosine theta. So what we graph is cosine theta. So we're going to graph cosine theta, and it's because cosine theta, because it's in the denominator. Okay. When we graph cosine theta, then we find the zeros. Those are our vertical asymptotes, and we make that general shape that is an upward shape for tangent, unless it's reflected, and then we'll reflect that. But that's the parent function, is an upward shape. But something that we had to remember for tangent theta is that the period is exactly half of what it was for the cosine that corresponded to it. So if the question asks about the period, we have to do exactly half. Alright, so let's do that for all of our functions that we're learning. Cotangent theta. So cotangent theta is equal to cosine theta over sine theta. Therefore, what we graph was sine theta. And once again, it's because it's in the denominator. And also, once again, cotangent theta is also a function that has exactly half the period. Of its corresponding denominator sign. Now, we also did cosecant theta and secant theta. So cosecant theta, that's the reciprocal of sine. So cosecant of theta is 1 over sine theta. Therefore, we're going to graph sine theta because it's in the denominator. And these are those U shapes. So we're going to practice all these. So if you don't know what I'm talking about with the U shape, we'll do that practice. And this time for the period, it's actually the exact same as the corresponding denominator. It's not half, it's just whatever that one was, it's the exact same. And lastly, we did secant of theta, and so secant of theta is 1 over cosine theta. So we graph cosine of theta because it's in the denominator, and once again, this is also the exact same, period. Okay, so we're going to practice graphing all 4 of these kind of mixed together, and we're also going to get the period, domain, and the range. So we're going to practice kind of everything we've done. So in example 1, I see cosecant theta as my trig, and cosecant is 1 over sine theta. Therefore, I'm going to be using the trig function of sine. Okay, so just pretend like this is a sine right here and do all the transformations according to that. So this 3 tells me to go up 3. This horizontal shift is inside the parentheses, tells me to go left, because it's plus, left 14. This minus sign does represent a reflection, so this sign is going to reflect, which means sine that's normally the S, well, it's still going to stay in S, but it's going to go down, up, and around instead. My amplitude is 5. My period, we are in degrees right now, so the period in degrees starts at 360 for the parent function, and we're going to divide it by this number we see here, which is 10. So you get 36. And those critical points, we need to divide that among 4 places evenly to get 9. Alright, so I need to go left 14, up a little bit, and draw my XY axis for that. So left a little bit, and up a little bit. So when I go left 14, it's going to land me here. So that's negative 14. If I add 9, I get to negative 5. If I add 9, I get to 4. So that's where I cross. So 1, 2, 3, 4. 1, 2, 3, 4. We're still just graphing sine as if this was a sine function. So I need to add 9. That's 13, 22, 31, 40, 49, and 58. All right, I need to go up 3, and from that up 3, that's my sinusoidal axis. Your vertical shift is always your sinusoidal axis. And then let's apply the amplitude of 5, so that's going to land me at 8 and negative 2. All right, now I need to graph a reflected sine. So it's going to start in the middle, then it'll go down, middle, up, middle. So it's going to start in the middle, and then it's going to go down, middle, up, middle, down, middle, up, middle. And if you want to go ahead and connect these points, that's perfectly fine. Just be prepared. I mean, y'all can go borrow a highlighter. You need to somehow indicate to me that this is not your final answer. And just highlighting your final answer is fine. So this is the sine graph that corresponds to this cosecant graph. So we know since sine is in the denominator, these vertical asymptotes, or I'm sorry, these sinusoidal points will represent vertical asymptotes, which I kind of just gave away. So let's mark our vertical asymptotes. These absolutely have to be marked for me to see. So this is one of my vertical asymptotes at negative 14. This is a vertical asymptote at positive 4. This is a vertical asymptote at 22, at 40, and at 58 is the last one. Now I need to draw in the U's. Cosecant and secant are those U shapes. So the U shapes are going to be these little tippy points right here, and so this is going to represent a downward U. This is going to represent an upward U, a downward U, and an upward U. And so in green, that is my final actual answer with the purple vertical asymptotes. Okay. All right, I do want to answer the question about domain and range and also the period. So a period is where it begins to repeat itself. So this downward arrow is going to repeat itself here. So this downward arrow happened at negative 14. And this downward arrow happened at 22. So from negative 14 to 22, that has a period, I'm just going to rewrite this, of 36, which if you notice is the exact same number that we wrote up here. That should happen for secant and cosecant. All right, domain and range we practiced just a little bit on Friday, but I want to refresh that. So domain is dolar, left to right. So if you just look at what we have here, we know that this continues forever, but let's look at what we have. At your left-hand side, your most left-hand side, you actually have this place that you're never going to touch. That's going to be something that your domain is going to have to skip. Your domain is also going to have to skip here at 4. Your domain is also going to have to skip here at 22. But everything in between is going to be okay for the domain. So there's no way to write this except set notation. And so set notation is the one that starts with a bracket, and we say x exists everywhere. So x exists in all real numbers such that, so we need to do an exception because we don't have actually all real numbers. But we're saying it exists everywhere, but x is not equal, so equal sign with a slash through it, is not equal to negative 14. And then from negative 14 to 4 is the addition of 18. So if you add or subtract, so it doesn't matter if you go in the negative direction, add or subtract 18 in, that's our what x will not equal. And then the last part is the range. Range is actually, I think, a little bit easier. So the range, I'm just going to have to pull this up. The range is, we can do the range still so range we're going to do in interval notation. So range is ribbit bottom. So bottom does exist. As I move to the top, though, I'm going to stop at, what was this value? Negative 2. So I have everywhere in the bottom, but I do have to stop at negative 2. I will touch negative 2. And then I'm going to skip up here. I start again at 8, and everywhere above 8 is okay as well. So 8 to infinity. And that's your domain and range. Okay, so this trig function is tangent, and tangent of theta is the ratio sine over cosine. So we're going to graph cosine of theta, because that's in the denominator. So we will move up 1. We will move left 3. We will reflect in this because of this negative sign. So that's going to make us start at the bottom. We're going to have a bottom U. And our amplitude is 6. And our period in radians is 2 pi, and we'll divide by that b value, which we see is pi over 6, which creates a period. Flip it, you get 12. And then divide 12 by 4, and we get 3. Okay, so let's go left a little bit and up. So if I want to see left a little bit and up a little bit. So when I go left 3, I'm going to end up at negative 3. And my critical points are 3, so I'm going to add 3 each time. So that actually gets me to first land on the 0. Then, so this is 1, 2, 3, 4. 1, 2, 3, 4. So I added 3, 3. So 0, 3, 6, 9, 12, 15, 18, and 21. My vertical shift was up 1. This is our new sinusoidal. And amplitude of 6 will land me at the 7 and at the negative 5. Alright, let's put in our dots for cosine. So that's going to be bottom, because we reflected, middle, on the 0, because we landed on 0, top, middle, bottom, middle, top, middle, bottom. And if you want to connect these, that's fine. If you don't want to, that's fine as well. I go back and forth, so it doesn't matter. Alright, now the real problem was to graph tangent, so we're not done. We know where it crosses the sinusoidal, which is here, 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 and here. We're going to create those vertical asymptotes. So here's a vertical asymptote. Here's a vertical asymptote. So I've done the 0, the 6, the 12, and the 18. And last part. This is tangent. Even though tangent is normally increasing, because this tangent will get reflected, I'm actually going to be decreasing. And I need to always land in the middle. So on 3, I'm going to be on the sinusoidal. So I'm going to be right here. Right here at the 9 on the sinusoidal. If you just want to do these 2 cycles, that's fine. I'm going to keep going though and do this last one. but the requirement is to do 2. So if you stop at 2, that's fine. And that's our tangent graph. Let's talk about period really quickly. So when we do tangent and cotangent, the period is always half of this number you see here. So the period is going to be 6. If you looked from 0 to 6, that's where it would start to repeat itself again. So 6 makes sense. Domain. So for tangent, domain is everywhere except these lines that are the vertical asymptotes. We're never going to touch those. So x exists in all real numbers such that x is not equal to 0 in any time we add or subtract 6. And our range is going to be bottom to top everywhere. I should note really quickly that this 0 doesn't have to be written, but if you do, that's fine too. All right, let's do the last example. So -4 minus 2 cotangent x minus pi over 2. So we have cotangent, which is cosine over sine. So that means we're going to be graphing sine. So if I graph sine here, then my vertical shift is down 4. My horizontal shift would be right, pi over 2. I will reflect, so sine will start middle, go with that s, and have an amplitude of 2. I'm going to take my period of 2 pi and divide it by 2 to get pi, and my critical points I'll divide by 4. So pi over 4, which doesn't reduce. Alright, so I need to move right and down. Okay, if y'all want to try to go ahead and graph this one on your own, and then I'll show y'all the answer. So right, pi over 2. When I add pi over 4, I realize I really kind of need a common denominator, so I'm going to erase this and instead write 2 pi over 4. So I'm going to add 1, 2, 3, 4. 1, 2, 3, 4. So 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and 9 pi over 4 is where I'm ending. I need to go down 4, and from -4 I'll go down 2 to land me on -6, and up 2 to land me on -2. Oh, and -4 is my sinusoidal. Okay, sine starts in the middle, and because it's reflected, it's going to go down, middle, up, middle. And I just realized I skipped this. So this should have been 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. So, whoops. I'm just going to continue. This is 6, 7, 8, 9, and 10. Okay, cotangent has a vertical asymptote here, 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 and here. And cotangent typically decreases, but because this cotangent is reflected, I'm actually going to increase. And I'll land here, here, and here. And that's it for cotangent. My period is going to be 2 pi over 4, or pi over 2 if you prefer. My domain, so x exists everywhere still, except it's not going to exist at 2 pi over 4 and anytime you add 2 pi over 4, plus or minus 2 pi over 4 in. And then the range is all real numbers. Alright, I'm going to go ahead and just take a look at y'all's homework and get y'all started. Yeah. Okay, so this is y'all's homework. What I'm looking for right here is just to put what the ratio is equal to. So for tangent, it's sine over cosine. For cotangent, it's cosine over sine. For cosecant, it's 1 over sine. And secant is 1 over cosine. So then we graph the denominators. Here I'm just looking for which 2 periods are cut in half and which 2 aren't. And then we start with some examples. This homework is kind of long, so let's ignore the last page, number 12 and 13. Don't cross them off, we'll do them in class together, but just go ahead and don't do them tonight. And that's it.